Now let's just move on further towards the question number 3, which says in figure. So let us suppose if I'll just take the figure. This is the figure x, y and x dash y dash. So x, y and x dash y dash, they are two parallel tangents to a circle with the center being as O and another tangent AB. So you can see there is another tangent AB to this circle with the center O, and it has a point of contact as nothing but C with the circle, and such that it is intersecting at the point A and the B at x, y and x dash y dash. Then we have to prove that this angle AOB is nothing but is equal to 90 degree. So we have to prove this AOB as nothing but 90 degree. So let's just start the solution for this one. First of all, let us suppose if I'll write it over here, that what we have to prove, we have to prove that the angle AOB is nothing but is equal to 90 degree. So let's just start the proof of this particular question. So we will start with the two triangles over here. So as you can see, we have a triangle POA. We have this triangle POA, or let us suppose if I'll call this as OPA, and we have this OCA. Let us suppose if I'm just taking these two triangles first. So in triangle OPA and triangle OCA, first of all, we know that this particular angle is nothing but 90 degree. We know about this concept already, that the radius is actually perpendicular to the tangent at the point of contact. So this angle is definitely 90 degree. And furthermore, we know that this angle is also nothing but 90 degree. Why so? Because again, this is nothing but a tangent. This is again nothing but a radii. So this is perpendicular to the tangent of this circle. So this is again 90 degree. So in triangle OPA and triangle OCA, first of all, we know that AP is equal to AC. AP is equal to AC. Why I'm just saying that AP is equal to AC? Because we know about this particular point, that this is an external point to the circle, and it is actually drawing the two tangents, that is AP and AC, to the circle. And we know from the theorem that whenever we will draw any particular two tangents from an external point, their length of the tangents are always equal. So AP is equal to AC because the length of the tangents are equal. The length of the tangents are equal. So I'm just using a theorem over here. So since we know that AP is equal to AC, and furthermore we know that OA is equal to OA. OA is equal to OA. Why? So it is nothing but a common side of both. It is nothing but a common side. And furthermore, we know about this concept that OP is nothing but is equal to OC. OP is equal to OC, since they are nothing but the radii of the circle. So they are equal to each other. So from this particular side, what can we say? That the triangle OPA is actually congruent to the triangle OCA by SSS congruency criteria. So hence, if they are congruent to each other, what can we say about the two angles? It implies that, let us suppose if I'm just taking as the angle 1. Let us suppose if I'm just taking this angle as nothing but angle 1, and this angle as nothing but angle 2. So what can we say about the two angles? If the two triangles are congruent to each other, so angle 1 is nothing but is equal to angle 2. Angle 1 is nothing but is equal to the angle 2. So let us suppose if I'm just taking it as nothing but the equation number 1. This is my equation number 1. Now in the similar manner, we will move forward towards the two triangles, that is nothing but the triangle OQB and OCB. In a similar manner, we will talk about OQB and OCB. So let us suppose we are talking about in triangle OQB and triangle OCB. First of all, OQ is equal to OC. They are nothing but the radii of the circle. Further, we can say that OB is nothing but is equal to OB. Why so? Because they are nothing but the common sides. And further, we know this particular fact that BQ is actually is equal to BC, because these are nothing but the length of the tangents which are drawn from an external point to the circle. BQ is equal to BC. They are the lengths of the tangent. They are the lengths of the tangent, and we know that the lengths of the tangent are equal to each other. So again, we can say that the triangle OQB is congruent to the triangle OCB by SSS congruency criteria, by SSS congruence criterion. We can say that these two particular triangles are congruent to each other, and since if they are congruent to each other, it means their angles are always equal, which implies that this angle, that is nothing but the angle 3, that is, suppose if I'm just taking it as angle 3 and I'm just taking it as angle 4, which implies that, so all this condition actually implies that angle 3 is nothing but is equal to angle 4. Let us suppose if I'm just taking it as equation number 2. I'm just taking it as equation number 2. Now furthermore, we definitely know about this fact that POQ is actually nothing but a straight line. Since we know that POQ is a straight line, so let us suppose if I'm just moving on further with the straight line. So since we know that POQ is a straight line, it is a straight line, which definitely means that the angle 1 plus angle 2 plus angle 3 plus angle 4, they are actually forming an angle of 180 degree, because they would be a linear pair. By the linear pair axioms, we know that this angle is nothing but a total of 180 degree. So hence all these angles would get combined with each other in order to give an angle of 90 degree. So hence we know that by linear pair axiom that all these angles should sum up together to give an angle of 180 degree. Now we know from the equation number 1 and from the equation number 2, angle 1 is actually is equal to the angle 2, and furthermore angle 3 is actually is equal to the angle 4. It means that in place of angle 1 we can write angle 2. So let us suppose if I'm just writing it over here, angle 2 plus angle 2 plus, it means further on in place of angle 4 I can write angle 3. So angle 3 plus angle 3 is equal to 180 degree. Why so? From the equation number 1 and 2 we can say about this fact. So further it would be 2 angle 2 plus 2 angle 3, which is equal to 180 degree. Let us suppose if I'm just taking 2 common out of it, angle 2 plus angle 3 is equal to 180 degree. Let's just take 2 towards the other side. So angle 2 plus angle 3 is nothing but 180 divided by 2, which is nothing but 90 degree, which implies angle 2 plus angle 3 is equal to 90 degree. So let's just see what is angle 2 and what is angle 3. So angle 2 is nothing but this angle, angle 3 is nothing but this angle. If I'm combining all these angles together, angle 2 plus angle 3, what is that angle? AOB. You can see all by yourself that angle 2 plus angle 3 is actually nothing but a whole angle, AOB. So it means that in place of angle 2 plus angle 3, I can write it as angle AOB, which is nothing but is equal to 90 degrees. So this is what we wanted to prove, that this angle is nothing but 90 degrees. So hence prove the fact that angle AOB is nothing but is equal to 90 degree.